We are in the final chapter on this course. It's going to be about different equations. The different equation that we're going to study kind of simple, and you're not going to use much calculus like derivative or integral in order to solve this different equation. It's going to be just algebra in order to solve this guy. Different equations that we're gonna study turn out to be the equation that we're gonna study the chain. However, the chain that we're gonna study kind of not continuous. So it's gonna be like the situation that you deposit some money into your saving account and it's not gonna compound continuously. It's gonna like a compound, give you a compound interest every 6 months or annually, and you're gonna have the daily temperature. So for this one, it's gonna be like the thing that you record day by day, so it's not gonna be all the time recording. So for the function that not continuous, the thing that you're gonna study is gonna be about different equation. So the different, okay, so the first order difference is going to be delta yx. So delta yx is going to be yx plus 1 minus yx. So it's going to be like the difference from one period to the next period after that. So it's going to be yx plus 1 minus yx. So that's going to be the chain. And the first order different equation will be the different equation that involving your delta yx that you have here. Okay, and it's going to turn out to be in the form of delta yx plus ayx, and it's going to be equal to the function in x called gx. Okay, the reason that we are studying here is going to be we like to solve for yx. So it's yx going to be the amount of something or the value of something at x period. Okay, so that is going to be our purpose. You see that this guy turned out to be kind of simple. Okay, so the first one that we're gonna study is gonna be about the homogeneous different equation. The homogeneous different equation is gonna be the equation that involving delta yx plus ayx, and on the other side the function gx turned out to be equal to 0. Okay, so in this case it's gonna call homogeneous. Homogeneous mean that you have the function gx equal to 0. So from your delta yx is going to be yx plus 1 minus yx. Okay, so that is going to be written in the form of what is called yx plus 1 minus yx plus ayx equal to 0. And you'll be able to write this guy as yx plus 1 equal to 1 minus a time yx. So this one will be the thing that we like to solve, and the thing that we like is going to be yx. So you plug in x equal to 1 into this equation. So you would get y1 equal to 1 minus ay0, and y2 you're going to get 1 minus ay1, and you see y1 from the previous step. So you have y1 equal to 1 minus ay0. So that is going to be your y1 that you're going to put in the second step. So you're going to have y2 equal to 1 minus a squared y0. Similarly, for y3, it's going to be y3 equal to 1 minus a y2, and it's going to be 1 minus a cubed y0. So you see the index here that you have 3. So the index that you have here is 3, and the index that you have 3 is 3. So for yx, it's going to turn out to be 1 minus a to the x y0. So that is going to be your solution. Okay. So in conclusion, if you have the different equation given by yx plus 1 minus ayx equal to 0, So for this guy, you see that the thing that important turned out to be A here. Okay, so it's turned out to be A here. So it's going to be yx plus 1 minus ayx equal to 0. So you're going to be able to get yx in terms of a and y0. So you get yx equal to a to the x y0. Okay, so you get yx equal to a to the x y0, like in this case. Okay, so this one is important and you need to know this formula. Or you can just ignore y0. Okay, so sometimes we can just ignore y0. We're gonna just have yx equal to a to the x multiplied with some constant c. Okay, so this one, you see that it can be written in terms of constant. Okay, so so it's going to be constant y0 and this guy is going to be constant c. Okay, and you can solve for c where c turn out to be just you plug in x equal to 0. Okay, so it's going to be, sometimes it's convenient to write the solution into this form. You're gonna see later why this guy is more convenient. Okay, you're gonna see this one in practice. And let's see. So you have yx plus 1 minus 4yx equal to 0. So this guy is gonna be a equal to 4. So you have a equal to 4. And you have y0 equal to 3. So you're gonna just answer yx equal to 4 to the x times 3. Okay, so that's it. You may, hey, that's it. You don't need to dip, we don't need to dip, we don't need to integrate. No, we don't. Okay, so no, we don't need to do anything much. So it's gonna be just yx equal to 4 to the x times 3. Okay, so this one will be just the final answer. Okay, so like I said, it turned out to be simple. Okay. So this one is called homogeneous and you have one side equal to 0. The second guy is called non-homogeneous. When you have non-homogeneous, it's turned out that you have gx on the other side. So it's going to be non-homogeneous different equation. So it's going to be in terms of delta yx plus ayx equal to gx, and you see you would want to solve this guy. Okay, so we be able to write the delta yx plus ayx, this first order guy, in terms of yx minus ayx. Okay, so a will turn out to be a constant. Okay, so this guy turned out to be a constant. And you have gx. Okay, so you have gx. Okay, so the way to obtain the solution for the non-homogeneous turned out to be you're gonna solve for homogeneous. So we're gonna assume that Zx satisfy the homogeneous guy. So you see the thing that you have in common turned out to be this part. This first order part turn out to be the same, zx plus 1 minus a zx, and instead you're gonna have 0 on the other side. So this one is gonna be zx satisfy the term that first order different equation is gonna turn out to be equal to 0. So it's gonna be homogeneous part. Okay, so this one is the homogeneous part of 1. Okay, so I'm gonna say this guy is homogeneous part of 1. Okay, and you have w satisfy the equation 1. So it's going to be, you have the homogeneous part and it's going to be one solution. Okay, so it's going to, here I'm going to say that it's going to be one solution for 1. Okay, so it's going to be one solution for 1. Okay, so it's going to be just one solution for one. We be able to generate other solution. Okay, so we be able to generate other solution by, you see that if you have the homogeneous part add by W, so you see here the gray guy are the same with different variable kind of. Okay, so let me highlight the gray and the pink guy. So you have the pink guy add by the gray one. So you see that this guy turned out to be 0 plus gx. Okay, so you have 0 plus gx. And you see that you can combine this z x plus 1 and wx plus 1 together, and you have a z plus wx equal to gx. So this one turned out to be yx plus 1, and this one turned out to be yx. So you have yx plus 1 minus ayx equal to gx, and you have yx plus 1 turned out to be a solution for the equation 1. Okay, so we are looking at the equation 1 here. Okay, so you see that the solution turned out to come from the homogeneous part. Okay, so homogeneous solution. Okay, and the thing that we call particular solution. Okay, so this guy W here is called particular solution. Okay, so it's gonna be particular solution. So you have the general solution. So this one will give you the thing that called general solution. So the general solution turned out to be consist of the one that from homogeneous solution. Homogeneous solution, let me highlight the gray one. So it's going to be coming from the gray solution, and it's going to another solution turn out to be coming from the pink solution. Okay, so it's going to be summing this one. So in order to obtain general solution, we're gonna find one solution for equation 1. Okay, so it's gonna be just one solution for equation 1, and we're gonna find the homogeneous solution. So it's going to be the solution from the homogeneous part. So you just ignore gx, and this guy turned out to be 0. And you're going to be able to obtain the thing that called general solution. General solutions mean all solution. Okay, so this general solution will give all solution for equation 1. Okay, so that is going to be kind of the thing that we are looking for. It seems hard to do. Okay, I have to accept something like that. However, I'm gonna teach you in the way that you should be okay for this one, and it's gonna be hard on algebra, not gonna be on differentiate, or it's not gonna be on integrate. Okay, so it's going to be depending on the gx. So you see you have gx, and the situation turned out to be two cases. The first one is going to be about you have gx is a polynomial. Okay, so you have gx is a polynomial. So if you have gx is a polynomial, the particular solution will be polynomial of the same degree with the unknown coefficient. Okay, so the general solution turned out to be just a polynomial of the same degree. So what does it mean? It means that if you would want to solve something like this, okay, so if you want to solve for the general solution for this different equation, yx plus 1 minus 9yx equal to 1, the first step will be, okay, so it's going to be step 1. you are solving homogeneous. So it's going to be yx plus 1 minus 9yx equal to 0. So for this one, you see that you have a equal to 9. Okay, so you have the capital A equal to 9. And this guy will give you yx equal to 9 to the x time constant c. Okay, so this c is a constant. Okay, so that will be your yx. The second step, so for step 2, you're gonna solve, okay, for wx, okay, so we have gx equal to 1. Yeah, so we have gx equal to 1. So it's going to be polynomial degree 0, polynomial of degree 0. Okay, so we're gonna let yx tilde. Okay, so this one is the thing that we use for particular solution. We can use wx, or this guys can be vyx tilde. Okay, and normally we're gonna let yx tilde equal to k be a particular solution. Okay, so we let yx tilde equal to k. K is going to be just polynomial degree 0. Okay, so it's going to be the same thing. Okay, same degree. So you have yx tilde equal to k. What we going to use? Okay, so it means that yx tilde plus 1 minus 9yx tilde will be equal to 1. Okay, so it means that it's going to be the solution that will satisfy the given differential equation. Okay, so this guy is going to be particular solution. What does it mean to be a particular solution? It's going to mean that it's going to satisfy your differential equation that, not differential equation, it's going to be satisfy the different equation that you like to solve. And you have yx plus 1 minus 9yx equal to 1, and you're gonna plug in for value. So you're gonna plug in yx tilde equal to k. So it's gonna be yx tilde equal to k. So this guy will be k, and this guy will also be k because it's turned out to be constant. Okay, so it's going to be k minus 9k. Okay, so it's going to be k minus 9k equal to 1. Okay, and you see that you can have negative 8k equal to 1. So you get k equal to 1/8. Okay, so you get k equal to 1/8. So in this case, okay, so in this case, you're gonna have the general solution will be given by yx equal to, okay, 9 to the x times c, okay, and you're gonna have minus 1/8. Okay, so it's gonna be this particular solution. So you have k equal to 1/8, and you have yx tilde equal to negative 1/8. Okay, and you're gonna use the general solution. Sorry, it's gonna be the blue guy. So you have this guy here. Okay, and you have the homogeneous part. The homogeneous part turned out to be here, and it's gonna be using here. Okay, so it's gonna be, you're gonna add these two guys together, and this one will give you the thing that called general solution. Okay. Okay, so this one will be the general solution. If the question gives you some initial value like y0 equal to what, okay, here you're gonna be able to solve for C. Okay, so I'm gonna solve for C for the next example. Okay, so you have yx plus 1 minus 3yx equal to 4 minus x. Okay, so this one is your gx. This one is your gx, and this guy will be your homogeneous. Okay, so this one will be your gx. Okay, so step one, you're gonna do the homogeneous yx plus 1 minus 3yx equal to 0. So you're gonna get yx equal to 3 to the x times c, where c is a constant. Okay, so where c is a constant. Step two, you're gonna have gx equal to 4 minus x. So you're gonna let yx tilde to be polynomial of the same degree as you have up there. So I'm gonna have a plus bx. Okay, so this one is degree 1, degree equal to 1. So when you have homogeneous, it's gonna, when you have gx is the polynomial of degree 1, so it's gonna be a plus bx, okay? So you're gonna find a and b. Okay, so we're gonna find a and b. So we know that yx plus 1 minus 3yx tilde equal to 4 minus x. Okay, so this one, the notation is called tilde, T-I-D-L-E. Okay, so the tilde. So it's gonna be the notation that we use here. Okay, so for this one, you see that you're gonna plug in x equal to x plus 1. So it's gonna be a b x plus 1. Okay, so that will be your yx plus 1 minus 3, and yx will be a plus bx. Okay, so this guy will be your y tilde equal to 4 minus x. Okay, so here is a little bit confusing, I know. Let me step by step with you with some color. So you see here that this guy, okay, so it's gonna be the pink guy, and you see that you put the pink guy here, okay, and you also see that here is gonna be your x plus 1 that you put here, okay. Okay, so I hope that it's gonna help you seeing this guy clearer. And you gonna simplify and expand. So you have a plus bx plus b minus 3a minus 3bx equal to 4 minus x. Okay, so you see that you're gonna have the term with x and the term without x. Okay, so you're gonna see that you have the term with x and you also have the term without x. So you're gonna conclude that you have a plus b minus 3a, so it's gonna be minus 2a will be equal to 4. So this guy is the term without x. And the term with x is gonna be b minus b, so it's gonna be 2b, okay, negative equal to minus 1. Okay, so you solve for b, it's gonna be 1/2. Okay, so you have b equal to 1/2, and you're gonna plug into this equation. So you're gonna get negative 2a equal to negative 2a equal to 3.5. Okay, so you have negative 2a equal to 3.5. So you would get a equal to negative 7 over 4. Okay, so you get a equal to negative 7 over 4. And where you gonna have your y tilde? So you're gonna get y tilde x particular solution given by, so it's gonna be uh, a equal to negative 7 over 4, okay, and you have 1/2 x, okay, so this one will be your y tilde x. So this one is the particular solution, right? So this one is the particular solution. Be a particular solution, be a particular solution. Okay, so you have this guy is a particular solution. So you're gonna have the general solution. So you'll be able to find the general solution. So it's gonna be just y x. Okay, so it's gonna be yx equal to, okay, 3 to the x times c. Okay, so it's gonna be 3 to the x times c, and you're gonna plus by negative 7 over 4 plus 1/2 x. Okay, so this one will be the general solution. Okay, so for this one, this guy come from the homogeneous part with the particular part. Okay, so this one will be just the sum between this one. I know that. Okay, so normally here it's gonna be kind of confusing. It's kind of confusing because what? Because you see that I use the same y here. So normally if you want, okay, if you want, in the case that you want only, you can just change this one to z. Okay, so it's gonna help you seeing something better. Okay, so it's not y, that variable, not y. Y won't satisfy that equation. So it's gonna be the z instead that will satisfy. Okay, so I know that it's confusing if I use yx and yx. So let me change this one here. It's gonna be z, it's gonna be z, and it's gonna be z. Okay, so it's gonna be the thing that you have. Okay, however, sometimes we just write y. Okay, so we not quite care. Just keep in mind that it's gonna turn out to be you need to solve for y, and the homogeneous mean that one side turn out to be equal to 0, and we kind of use the same y for that. Okay. The next thing is going to be, you're going to find C by using, okay, so we're going to find C by using y0 equal to 1/4. Okay, so we're going to find C by using y0 equal to 1/4. So we're going to put y0, so it's going to be 1/4 equal to y0 equal to C plus negative 7 over 4. Okay, so you get C equal to 2. Okay, so you would get c equal to 2 in this case, and you get the solution yx turn out to be 3 to the x times 2 minus 7 over 4 plus 1 over 2x to be the solution for this different equation. Okay, so this is what you have. Okay, you may check the solution by plugging yx into the original equation in order to see whether you get the original guy. Okay, however, I'm not gonna show you this one. Okay, so it's gonna be kind of long to do. Or should I? I think it should be okay. Let me add. Okay, so let's check solution. Okay, so let's check solution. Okay, so if you want to check the solution, you're gonna have what? You're gonna have yx equal to 3 to the x times 2 minus 7 over 4 plus 1 over 2x. Okay, so it's going to be here, and you're going to have yx plus 1 minus 3yx. Okay, so it's going to be 3 to the x plus 1 times 2 minus 7 over 4 plus 1 half x plus 1. Okay, so this is your first term, minus 3 3 to the 3x times 2 minus 7 over 4 plus 1 half x. Okay, and you see that this guy and this guy, let me multiply first. So it's going to be 3 to the x plus 1 times 2 minus 7 over 4 plus 1 half x. Okay, and you see that it's going to be plus 1 half minus 3 to the x plus 1 times 2, and you see this guy is going to be plus 21 over 4 minus 3 over 2x. Okay, and you see that this term and this term disappear, and you have this term and this term, so you have 21 minus 7, so it's gonna be 14, right? So it's gonna be 21. So it's gonna be, let's combine this guy also. So you have 3 constant. So you see that it's gonna be 14 plus 2, so it's gonna be 16 over 4. So it's gonna be 16 over 4. So this one is the red one. And you have this term and this term. This guy will be minus x. Okay, so it's going to be minus x. So this is the term. So you see that it's turned out to be correct. Okay, so it's going to be 4 minus x. Okay, and you can also check that y0 equal to 3 to the 0 times 2 minus 7 over 4. Okay, plus 1 half times 0. So it's going to be 2 minus 7 over 4 equal to 1/4. Okay, so this one will be everything correct. Okay, it satisfies that that different equation, and it gonna satisfy the initial condition as well. Okay, so this will be just different equation that you have. Okay, the next one, you see that everything turned out to be repeat again. So for this one, you have the homogeneous part here, and you have the particular part, so gx. So you have gx equal to 32x squared, and you have the step 1, you have the homogeneous, So you have yx plus 1, or should I write z? Okay, zx plus 1 minus 9zx equal to 0. So you would get zx equal to 9 to the x time what is called z. Okay, and step 2, okay, you're gonna let y tilde x equal to, so this one is polynomial degree 2, polynomial of degree 2. So you have yx tilde to be a plus bx plus cx squared be the particular solution. Okay, so you get the particular solution yx tilde equal to a plus bx plus cx squared in that case. And then you're gonna have yx plus 1. Okay, so yx plus 1, so it's gonna be a plus bx plus 1 plus c x plus 1 square minus 9 a plus bx plus cx square equal to 32x square. Okay, so you have a plus bx plus c x plus 1 square minus 9 a plus bx minus cx equal to 32x squared. Okay, so help me check the number. So you have a plus bx plus b plus c times x squared plus 2cx plus c. Okay, so that should be correct, right? Cx squared plus c, yeah, it's correct. And you get negative 9a minus 9bx minus 9cx squared equal to 32x squared. Okay, and you're gonna see the coefficient of x squared. So you have coefficient of x squared, so it's gonna be negative 8c. Okay, so let me have this guy. So you have negative 8c must be 32. Okay, so that's the first one. And you have the coefficient of x. Okay, so it's gonna be negative a, so it's gonna be 2c. Okay, so it's gonna be 2c. Okay, so this one is gonna be 2c minus 8b equal to 0. Okay, and finally you get a, b, c, okay, minus 9a, okay, so it's gonna be negative b plus c minus 8a equal to 0. Okay, so this one is come from degree 2, degree 1, and constant term respectively. Okay, so it's gonna be this three guy. Yes, let me erase, let me change the color a little bit. And for this one, it's gonna be color. Okay, so it's gonna be three guy like this. So you see that you can solve for c equal to negative 4. Okay, so c is negative 4, and you gonna have b. Okay, so it's gonna be negative 8, so it's b gonna turn out to be negative 1. Okay, so b gonna be negative 1, and you will have a So it's going to be b plus c, so it's going to be negative 5, right? So it's going to be 5 over negative 8. Okay, so it's going to be a. So this allows you to have yx tilde equal to negative 5 over 8 minus x minus 4x squared. Okay, so that is going to be A, B, and C that you are looking for this solution. So this guy will be this, okay? And you have the homogeneous part. So you're gonna have yx equal to 9 to the x times c, okay, minus 5 over 8 minus x minus 4x squared, okay, to be your general solution. Okay, so this one come from this homogeneous, and it's gonna another part come from the particular part. Okay, so it's gonna be this equation. Okay, so you see this is the first case that you have polynomial. Okay, we're gonna have the particular solution in another case which turn out to be the exponential. Okay, so it's gonna be in the next clip.